Hello guys. Hello guys. So last time we've stopped at section 1.4 and today we're gonna continue with 1.5. So briefly already studied, however let me go one more time. So I hope you can see it. So solutions of linear equations, right? Last time we discussed about homogeneous linear systems. Let me remind you. So a system of linear equations is said to be homogeneous if it can be written in the form a times x equals 0, where a is m by n matrix and 0 is a zero vector in Rm, right? Such system always has at least one solution, namely x equals to 0. So it's a zero vector in Rn, right? And when we get a solution like x equals to 0, it's called a zero solution, and we also can call it trivial solution. Okay, it is guaranteed that your system x a times x equals 0 at least has a one solution. Okay, and now the question is the is it the only one solution? Okay, so for equation, for example, a times x equals 0, the important question is where there exists a non-trivial solution. Okay, what does it mean? It means that non-zero vector x satisfies a times x equals 0. Okay, so you have to find a solution which differs from x times 0. Okay, so this is the important question. So difference between trivial and non-trivial solution is in that. Okay. Homogeneous equation a times x equals 0 has a non-trivial solution if and only if the equation has at least one free variable. So what you need to look for is at least one free variable. If you have at least one free variable, then you say that your system has a non-trivial solution. Okay. And from the textbook example, you have to determine if the following homogeneous system has a non-trivial solution. Then describe the solution set. Okay. So the linear equations are given right here. Let's construct the augmented matrix. What does it mean? You know already, right? You just write the coefficient matrix and add zeros. I mean like the values, corresponding values, okay? So in this case it's 0, 0, 0, 0, right? Then we reduced it, use the first two rows, and we got the following matrix, and further reduction gives you this solution, right? So 3 5 minus 4 0 0 3 0 0 0 0 0 0, right? So from here, as I already taught you, right, you say that your x3 variable is your free variable, right? And a times x equals 0 has non-trivial solution for one for each choice of x3, correct? So to describe the solution set, continue the row reduction A0 to reduce echelon form, right? To reduce the echelon form. So as I said, we always strive for or want to reach the solution in the form such like this, right? Please notice that we cannot reduce it more because here we don't have a pivot, correct? If we had a pivot, we can reduce this element. Therefore, let's rewrite it from the matrix form into linear equations. So x1 minus 4 over 3 x3 equals 0, x2 equals 0, 0 equals to 0, correct? From here, you have to express x1 like 4 over 3 x3, correct? Just move this one to other side, and your x2 equals 0, and your x3 is free variable, correct? And last time I showed you how we can do that. For example, x equals x1, x2, x3, and let's substitute the values. Your x1 equals this value from here, correct? Your x2 equals 0, your x3 stays the same. Now let's factor out x3 from the vector, and you get x3 times this matrix 4 over 3, 0, and 1, correct? And you can see that you can write in the form x3 times v, where v equals this vector, correct? Yeah, so here's x3 is factor out of the expression for the general solution vector. This shows that every solution of a times x equals 0, in this case, is a scalar multiple of v, correct? The trivial solution is obtained by choosing x 3 equals 0. So just substitute x3 equals 0 and you get a 1 solution. Right. So this was what we was doing in the classroom, correct? Now the second example, take this equation and do the same stuff. Sorry, if I'm mistaken. Yeah, so take this linear equation and just do what we did already, right? So we get something like this: x2 times 0 0.3, 1 and 0, plus x3 times 0 0.2, 0 and 1. And here you get x2 and x3 free variables. Let's denote the first one, the first vector, like u, and the second vector like v, correct? So you can just write x equals to x2 times u plus x3 times v. So this is what I was writing. And we also introduced with the notion of parametric form of vector. So I said that it can be written x equals to s times u plus t times v, where s and t in R, correct, is some kind of let's say numbers, right? Real numbers. Yeah, so we considered this example. So your matrix A is given, your another vector is given 7 1 and minus 4, 7 minus 1 and minus 4, and you have to determine the solutions of A times x equals b, correct? So yeah, you did the same procedure, and you can notice here we don't have a pivot to reduce it. Therefore, we write in the form x1 minus 4 over 3 x3 equals 1, x2 equals to 2, 0 equals to 0, correct? And we rewrite it in the form x equals x1, x2, and x3. We expressed x1 and x2 and x3, correct? And we factor out everything, like in the first vector we write like minus 4, like just three numbers, right? Minus 1, 2, and here we can write 0, correct? And plus what in the second vector we write what we left with. So 4 was 3, x3, 0, and x3, right? So let's denote the first metric as, sorry, first vector like p, the second one as v. And we can rewrite x equals to p plus x3 times v. So this is our parametric form. Okay. So also we studied this theorem. You can read it by yourself. And here is a general procedure. For example, writing a solution set of a consistent system. Consistent system you already know if you have one solution or infinitely many, correct? In parametric vector form. So first, as I always say, row reduce the augmented matrix to reduced echelon form. Express each basic variable in terms of any free variables appearing in an equation. Third step is write a typical solution x as a vector whose entries depend on the free variable, if any. And fourth, decompose x into linear combination of vectors, okay, using the free variables as parameters. Okay, let's now practice the examples, okay? And here I've written two solutions. So it's like 2 minus 5, 8 and 0. Here's minus 2, minus 7, 1 and 0. Here's 4, 2, 7 and 0, correct? So let's use the first two rows and reduce it. So it's going to be 2 minus 5, 8, 0. Here we say, if we just sum them together, so minus 5 plus minus 7 is going to be minus 12. 8 plus 1 is going to be 9. Here is going to be 0. And here, let's, for now, let's rewrite it in this form. Okay, let's leave it. Now we need to multiply by minus 2 and add with the fourth row. Okay, let's do it. 2 minus 5, 8, 0, 0 and let's divide this one by minus 3. So we gonna get it's gonna be 4. We're gonna be minus 3, correct? And here we're gonna get 0. 10 minus 5 times minus 2 is 10. And what we do is add them together. And here we get minus 16 plus 7 is going to be 9. Sorry, minus 9. We're going to get something like this, okay? And what we notice is here, this one and this one will absolutely get here. So let's multiply by minus 3 and add to this row, okay? So what we're going to get is 2 minus 5, 8, 0, 0, 4 minus 3, 0, and we're gonna get 0. 4 times minus 3 is minus 12, plus 12, we're gonna get 0 here. Minus 9, minus 3 times minus 3 is gonna be plus 9, plus minus 9 is gonna be 0, and here is gonna be 0. So even from here, you can say that you have a free variable, correct? But let's reduce it further, okay? So what we're gonna do here, let's divide this one by 4. So what we're getting is, so 0, 0, 0, and here 0, 1, minus 3 over 4, 0, so sorry, here's minus 3 over 4, okay? And here, let's put it like it is. Okay, so now we have a pivot here, we need to reduce it here, right? So let's multiply by 5 and add them together. So we're gonna get 0, 0, 0, 0. Here 0, 1, minus 3 over 4, 0. And now let's multiply. It's gonna be 2 here. It's gonna be 0 here. So what we're doing is multiply by 5 and add them together. Okay, it's this one. So 5 times 3 is 15 over 4, right? So it's gonna be like minus 15 over 4 plus 8. Okay, so it's gonna be 32. Sorry, so it's gonna be minus 3, 2 over 3 plus 8. It's gonna be 4, 3, and 1, I guess, correct? Yeah, should be correct, yes. So here we write just 13 over 3 here. And now let's divide everything by 2. So we're gonna get 1, 0, divide by 2. So we're gonna get 2, so 13 over 3 divided by 2 is gonna be 13 over 3. Sorry, 13 over 6 here. 1 minus 3 over 4, 0, and here is zeros. And now, let's express in the form like x1 equals 13 over 3, sorry, 13 over 6, x3, x2 equals 3 over 4, x3, x3 equals 0, correct? Oh, no, not 0, sorry, it's free variable. And now what we do is x equals, as I will say, x1, x2, and x3, and let's express it in this form. So let's substitute the, oh, sorry, I'm trying to get comfortable with this writing. So over 3 x3, here is 3 over 4 x3, here is not 0, sorry, x3. Let's factor out x3, we're gonna get something like this, something like this, and 1. So this is my vector p. Okay, so that's it for today. Thank you very much for this, for your attention, sir.